we've been having a look at exponentials. If the exponential was the world's easiest derivative, guess what? It's going to be the world's easiest integral as well, because we're just going back the other way, of course. So if I've got an integral of an exponential, but notice I've made it a linear function in the top, so just some coefficient of times x, then it would be 1 over a. When we differentiated it, we multiplied by the derivative of the power. So when I integrate, I'm hesitant to say divide by it. It only works because it's a linear function. In more detail, I suppose, it's similar to those. Do you remember those ones we looked at last year and we said what we wanted to create was the derivative times some function to the power of n? It's the same sort of idea. What we'd like to create is a derivative times e to the function x, because we know that's the answer. So therefore, if I can get it in that form, then when I integrate it, I must go back to just e to the function x. Because when we differentiate, we go derivative times e to the function x. So we want to try and get the integral as derivative times e to the function x, and then we know the answer would just be e to the function x. So all right, integral of e to the 5x. It is a linear function, so I can in this case just go 1 divided by 5, the derivative of 5x. That works fine. Of course, the other way I could think about it, if I wanted to think about it the second way, I would have said, well, e to the 5x, I'd like it as derivative times e to the 5x, and the derivative times e to the 5x would be 5e to the 5x. Can't just change the question. So to balance it out, I multiply by a fifth out the front, and then I know, okay, I've got derivative times e to the function, so it just becomes e to the function x. That's probably a little bit silly for, as I say, the linear function. So if the power is a linear function, we know we can just go 1 over whatever the coefficient of x is out the front. But here, with something like this, x e to the x squared, I can't do that. Hey, I want to create the derivative out the front. The derivative is 2x. To balance that out, I need a half out the front. I now have the integral as 2x e to the x squared. Oh, I know that will become e to the x squared, and there's the answer, half e to the x squared. This one is a linear function, so that's okay. I can just go 1/9. Oh, actually, I'm doing it the long way, aren't I? Look at that. 1/9, I've created derivative times e to the function. But of course, I could have, because it was a linear function, just gone 1 over a, or 1 over 9 in this case. Square root of e to the x. Again, got to be real careful here with our index laws. That would be e to the x all to the power of a half. So in other words, it becomes e to the half x, or x on 2. It's a linear function, so I could do it that way, but I'm going to create the derivative. I think I would have. Yes, I did. So the derivative is a half e to the x on 2. To balance it out, then 2 I need out the front. And I get 2e to the x on 2. And of course, look, I just always am in the habit of, however they ask me the question, I put it back in that form. So they use surds. I put the answer in surds. Reality is you'd probably get full marks for that second last line when you've done the integration. Okay, we don't have a product rule for integration, you remember. So I'm going to need to expand this out. Again, being careful. E to the x times e to the x is not, that's right, it's not e to the x squared. Common mistake, it's e to the 2x. So expand that out, we get e to the 2x minus 2e to the x minus 3. Integrate each of those individually. I'll get a half e to the 2x. Again, a linear function, so I can just go 1 over 2. E to the x, world's easiest integral. Integrate e to the x, we get e to the x. And then 3, of course, becomes 3x. We don't have a quotient rule like we do. So here I'm going to have to do a division. When we divide, we subtract the powers. So e to the 5x divided by e to the 2x is e to the 3x. And the other one becomes x minus 2x, e to the minus x. And so we get 1/3. Again, nice linear powers, so we can do it the easy way. Very careful with your minus and plus signs. Another spot where we could make an easy mistake there, because negative times negative and all that sort of stuff. Oh, let's do a definite one. Are you sure? Yes, I'm definite. Okay, so x squared e to the x cubed. Oh, I'd like the derivative out the front. The derivative of x cubed is 3x squared. That becomes e to the x cubed, and the limit's 0 to 1, so it becomes e to the power of 1 minus e to the power of 0. A third e minus 1. Remember yesterday we looked at how we differentiate ones where the base is not e? And what we ended up doing was multiplying by the natural log of the base. Well, integration, we're going back the other way. So I can still do it the same, but I will divide by the natural log of the base. So 3 to the power of x will become 3 to the power of x divided by the natural log of 3. Okay, so 13C, 13D, enjoy.